Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue talking about actors, and we're going to look at the Scala.actors package and how we write code with it that involves actors. Now, one thing that I have to note, this package is basically in the process of being deprecated. It's covered in the book because of the time frame the book has been written in, but Scala evolves over time. I'm covering it here in the videos because it is in the book. But I'll write some videos where I talk about the package that is going to supersede those, and basically that's the ACA library for actors. So if we look in the API, there's this Scala.actors package, which has a number of classes in it. We've actually seen these previously. Back in the chapter on multi-threading, I briefly introduced this actor object and the fact that we could call actor and pass it a body in order to have something start off in a separate thread. We also talked about the futures object and the ability to create a future in a similar way, with the difference that a future can give you back a value, and so we used our future objects to get back values when we had them calculated off in threads. Even this is not what you would use in the newest Scala standard. There is a new approach to futures, and we'll also talk about that in a few videos. But now we want to talk about the actors in the context of really doing actors. So how do we write code that involve actors? Well, the first thing you note in an actor is that it has this method called act, which makes sense. And it is abstract. So when you create your own actors, you're actually going to write your class and implement the act method. Basically, that's what the actor object is doing here, is it's creating a little class for you, and it's putting this inside of the act method, and then it's starting up the actor. Actors do have to be started. If you don't start them, they don't do anything. So when you do this act and you start things up, that happens off in its own thread, and we can write a little code to demonstrate that. We'll go ahead and put it inside of here, make a Scala object called actor test. Okay, we define our main, and to illustrate this, let's go ahead, actor equals a new actor. We're just going to make this as a little inner class here, just inline it. Let's import actors._, so that it can find that. And we have to write the act method to make it happy. So what do I want to put in my act method? I'm going to do something fairly simple. And not only, I'm going to do something fairly simple and something that we should not do in actors, but it's for illustrative purposes to make sure that we understand this is happening in a separate thread. So I'm going to take for I in 1 to 26, print line I thread.sleep for 100, capital T in my thread there. Okay, that creates an actor. We have to start it to make it happen, and then back out here in the main thread, we're going to write a for loop that takes a character between A and Z and basically does the same thing. Okay, just to verify that this is all happening in separate threads, you can see what happens here. 1A, 2B, 3C, etc. Because I have them sleeping that period of time, they alternate nicely. If we were to take out the sleeps, it's not exactly clear what would happen on this. I think a lot of the times, and this is the reason I included the sleeps, a lot of the times, yeah, one of them because printing 26 is such a fast thing to do, that this winds up happening before the main thread ever comes in and gets hold of these things. I wonder if we can get any type of weird interleaving if we just speed this up. There we go, that's good. So most of it is interleaved because they have equal threads, but this thread managed to get off 1, 2, 3 before the other one started with A, and so then the other one had X, Y, Z there at the end. Okay, so, but the main point here is this is happening in a separate thread than this, and our simple way of making this happen is we create a new actor, and then we call actor.start. Now, what's more interesting about this is what we can put inside of this act method to make it so that our actors behave the way that they're supposed to properly implement the actor model. And I'll come back in the next video and we'll talk about message passing and how we get messages inside of our act method.